Okay, so for my model, the question I chose was, which kind of ended up changing a little bit, but it was essentially about how can we model neuronal tissue dynamics with age. So, um, it's definitely not. I mean, there's a lot to do with this, and I think I might want to do this for my final project. But essentially, there's and initially there's three states, right? There's an empty cell without any neuron, any type of neuron, and then there's an immature neuron, and then a mature neuron. So a few rules is that like an empty cell that has it says it right here. An empty cell with at least three neighboring immature neurons becomes an immature neuron. So if there's an empty cell with three surrounding it, it'll become one. It basically the idea is that the three immature neurons will grow um, to their neighbor. So another thing is that an immature neuron will become a mature neuron after a certain number of time steps. So, like in reality, that's after 25 years, your brain is fully developed. For example, I mean, essentially that kind of dynamic I'm trying to model here. Another one, this is the more complicated one that I'm still working on, is that mature neurons, they will remain mature, but if they're surrounded by three other either mature or immature neurons, they'll send kind of a signal, which in practical sense would mean a new neuron connection, so that it basically what I'm trying to do is if that condition is met, it's going to pick a random neuron in a certain area and make or random immature neuron in a designated area and make that immature neuron to a mature neuron. And I'm trying to like work on the dynamics of like I want to have like the signal like be sent to it and then just like look like a I don't know, like a laser beam or a bullet, like an actual signal, but the logic is kind of hard for that. But anyways, as for code, the first thing I have is a short pathfinder algorithm that's literally just magnitude of the path of like the vector of the path, and I'm just ignoring all other neurons and other obstacles, which is a greatly simplified model. Otherwise, I'd have to use something like A star or like go to goal maneuver, like an actual pathfinding algorithm. But this is just straight up magnitude of a vector. But then I have I have my initial conditions are like obviously initial size of the grid, and then total number of time steps, which kind of would represent like you could say year, number of trials. The connection range is when the condition is made for a mature neuron having neighbors. The connection range is the matrix it chooses the signal to randomly go to. It's kind of hard to explain. I think I'm explaining it right. I'm not sure. But yeah, and then it pretty much loops through the grid. And here is where I'm experimenting, which is not great. But essentially, right now it's doing is we're getting a path from our pathfinding algorithm, and then every iteration we're updating the cell along that path to be like a connected neuron. So it doesn't look pretty because it's just gonna like look like a straight blue line of cubes, and it doesn't like update it nicely, but it's okay. And then just the other for loops for just the simulation. So I guess I'll run it, but to show. So trial one. So as you can see, it like there's a little green flash at the beginning. That's just the immature neurons, and I need to there's trial two, but I'd like to adjust the density of things and make everything a lot slower, but I don't have a ton of time to. But as you can see, there's dynamics, but it happens in a very short time frame, and you'll see that with the graphs. And I want to change this eventually, but yeah. And then it's gonna do that. And then an example of a graph it looks like this. I mean, the rise time is like literally 2 time steps, which definitely needs to be adjusted. But the dynamics are there. What else do I have to present here? So results aren't perfect, but I think that for the like the dynamics I'm using, it's definitely hard to like get right because there's a lot of different variables, and there's also stuff like I'll just keep thinking of different things to add to the model, which obviously increases the complexity of the model itself. So yeah, but I think it's pretty cool so far, and you can see like there's a little bit of randomness here. That's why I have different trials. So um, yeah, it's basically based. The randomness here is only based off the initial condition of the initialization of the grid. Now, right now, it only initializes the majority of it in our initializes mature neurons, and it's not exactly like calibrated for changing the density, which I want to change. But um, yeah, that's kind of what I'm doing. That is what I'm doing. Thanks.